Annually, there are 150,000 lower limb amputees in the United States of America. 63 to 82% of lower limb amputees experience pressure injuries.
A pressure injury can occur to prosthetic users if preventative measures are not taken.
To better understand current clinical practices, we met with prosthetists both in person and virtually to discuss how high-pressure areas are currently identified and managed.
Currently, clinicians primarily rely on physical examinations, patient feedback, and overall subjective assessments.
Our team investigated a method for clinicians to collect pressure data to identify areas that are at high risk for developing pressure injuries to help improve prosthetic fit for transtibial amputees.
Hi, this is Bioengineering Senior Design Team 4, and this year we developed a pressure-sensing prosthetic sock for clinical use.
Our team started off by drawing a storyboard to better plan out our design steps.
We decided to split our workload into two different areas, the circuits aspect and the soft goods aspect.
Using resistive pressure sensors, a data acquisition system, and microcontrollers, we created prototypes to wirelessly transmit data via Bluetooth to a graphical user interface for visualization.
To secure the circuits into place, we designed a custom housing to protect and vent the electronics while positioning this at the amputee's waist to minimize interference during use.
In parallel, multiple iterations of the prosthetic sock were developed. Initial designs used basic materials to demonstrate sensor placement. During early iterations, thermoresistive fabric was explored as a potential safety feature to mitigate heat-related risks. However, based on sensor specifications and testing, it was determined that the sensors did not reach high enough temperatures to pose a burn risk. As a result, the final design was refined to incorporate 3-ply elastic fabric comparable to athletic compression wear, along with improved sewing patterns and structural features to better secure sensor placement and maintain overall fit.
With help from prosthetists at Hanger Clinic and Pitt O&P students, we developed 2 lower limb models
to assist with future testing.
Following integration of these subsystems, a complete engineering prototype was developed and evaluated through verification and validation testing.
This included repeated donning and doffing cycles to assess structural integrity, battery endurance testing to ensure sufficient operation time, calibration testing to confirm measurement accuracy, and more. Additional testing, such as cleanability and material evaluation, was conducted to assess the performance of the sock under repeated use. Clinicians were guided through use-based protocols to interact with the system and assess the graphical user interface, including data visualization and workflow integration. Additionally, a lower limb amputee tested the pressure sensing sock to evaluate comfort, fit, and overall usability during simulated use.
Following each session, structured questionnaires were completed to evaluate the comfort, usability, and perceived effectiveness of the system.
Ultimately, our verification and validation results confirm that the system performs as intended and has demonstrated strong potential for impact in the prosthetic field.
Thank you, and hail to Pitt.